Hello everyone. Today we will learn about reduction formula. See, whenever a formula which expresses an integral in terms of another which is simpler form is called a reduction formula. So this reduction formula are generally we can get this reduction formula by integration by parts. So let us see some of the reduction formula and their formulas. So number one is integration sine to the power nx dx. Here n is greater than 1 and is a positive integer. Okay, it's a positive integer. Now I will derive one formula. I will derive integration sine to the power nx dx, and after that I will only write the formulas only because we have to see the applications. Otherwise, video will be too long. So let us prove this, or let us find the formula of integration sine to the power nx dx. Let us say this is our Jn, that is integration sine to the power nx dx. So we can write this in this format: sine to the power n minus 1 x into sin x. If the powers are added, then you will get sine to the power nx. Now see, here we have to apply by parts. Let us say this is our first function and this is our second function. So our by parts would be sine to the power n minus 1 x into integration of sin x, that is minus cos x, minus integration of ddx of sine to the power n minus 1 x. So differentiation would be n minus 1 sine to the power n minus 2 x, because for power we know it is n into x to the power n minus 1, and differentiation of sin x would be cos x into integration of sin x, that is minus cos x, again dx. So it would be minus sine to the power n minus x into cosine of x, minus minus will give plus n minus 1 integration sine to the power n minus 2 x, and this is cos square x, so we can write it as 1 minus sine square x dx. So it would be minus sine to the power n minus 1 x cos x plus n minus 1, and if we break this, this will be integration sine to the power n minus 2x dx minus n minus 1 integration sine to the power n minus 2x into sine square x, that would be sine to the power nx dx. Okay, now let us say this is our sine to the power n minus 1 x cosine of x plus this is n minus 1, and if you notice our Jn is integration sine to the power nx dx. So sine to the power n minus 2 x dx would be Jn minus 2. So this would be n minus 1 Jn minus 2 minus n minus 1 into Jn. And if you take, this is our Jn, if you take this term in the left hand side, so it will be Njn, this is plus Jn, and this is, if it comes in the left hand side, it will be minus Jn, so Jn will cancel out, so we'll get Njn minus sine to the power n minus 1x cosine of x plus n minus 1 into j n minus 2. So our formula for nth integration would be, formula of Jn is minus sine to the power n minus 1x cosine of x by n plus n minus 1 by n into j n minus 2. Okay, so that's all you have to remember. Now let us see our second reduction formula for integration 0 to pi by 2 sine to the power nx dx. Remember, here n is greater than 1, which is a positive integer. Now let us say this is our in. We have just found out that we can say that in is actually Jn, which is this, putting the limit 0 to pi by 2. So we can say Jn from 0 to pi by 2, which is in, and you have to put the limit here from 0 to pi by 2. So it will be minus sine to the power n minus 1x cosine of x by n from 0 to pi by 2 plus n minus 1 by n into jn minus 2 from 0 to pi by 2. If you put the limit here, cos pi by 2 would be 0 and sin 0 would be 0. So in both the case it will be 0. So this is our in is 0 plus n minus 1 by n into jn from 0 to pi by 2 is in, then jn minus 2 from 0 to pi by 2 would be in minus 2. So we can say that this integral is in, which is n minus 1 by n into n minus 2. This is the formula you have to remember. Okay. Now let us see one example. It is evaluate in 0 to pi by 2 sine to the power 6x dx. And remember, doing this type of integration without reduction formula will take a lot of time. So it is highly advisable that you should use reduction formula. So we know it is in the form 0 to pi by 2 sine to the power nx dx. So we can say that we have to use in is n minus 1 by n into n minus 2. So for this, what you have to do, you need I6. So what would be I6? I6 would be 6 minus 1, that is 5, by 6. This is I6 minus 2, that is I4. Now you need the value of I4. So what would be I4? I4 would be 4 minus 1, that is 3 by 4 into I4 minus 2, that is 2. Now you need the value of I2. So I2 would be 2 minus 1, that is 1 by 2 into 2 minus 2, that is 0. So I0. Okay. So what is I0? This is In. So if it is I0, then in place of n you have to put 0. So this would be integration 0 to pi by 2 sine to the power 0x dx. Sine to the power 0x is 1. Integration of dx is x from 0 to pi by 2. So upper limit minus lower limit, that is pi by 2 minus 0, that is pi by 2. So I0 is pi by 2. So if I0 is pi by 2, then you can say what would be your I2? I2 would be half of pi by 2, right? Then it will be 3 by 4, half of pi by 2. Then it will be 5 by 6, 3 by 4, half of pi by 2, right? In this way it will go. So we can say that our I6 is 5 by 6 into I of 4. I of 4 is 3 by 4 into I of 2. I of 2 is half of I naught. I naught is pi by 2. Okay. And if you calculate, you will get I6 as 5 pi by 32. Now let us see. Sometimes they directly give this question that derive the formula for sine to the power nx dx. So in that case you have to remember the by parts, how to solve this. So now we are going to see reduction formula for cos to the power nx dx. So this is our number 3 reduction formula, that is integration cos to the power nx dx, and n is greater than 1 and is a positive integer. So let us derive. Let Jn is integration cos to the power nx dx. So we can write it as, this is the same method you have to follow. So cos to the power n minus 1x into cosine of x dx. We can write this. If you add the power, you will get cos to the power nx dx. So now we have to apply by parts here. So let us say this is our first function, this is our second function. Cosine of n minus 1x, integration of cos x, integration of cos x is sin x, minus integration ddx of cos to the power n minus 1x. This would be n minus 1 cos to the power n minus 1, that is n minus 2x, and differentiation of cos x is minus sin x, and integration of cos x is sin x dx. So it would be cos to the power n minus 1x sin x. Here minus and minus will be plus. Integration n minus 1 will go outside. It would be cos to the power n minus 2x into sin x into sin square x. So we can write it as 1 minus cos square x dx. Okay. Now it will be cos to the power n minus 1 x into sin x plus n minus 1 into integration. If we break this, it will be cos to the power n minus 2x dx minus cos to the power n minus 2x into cos square x, that will be cos to the power nx, and outside we have n minus 1. Integration cos to the power nx dx. So you can say this is cos to the power n minus 1x into sin x plus n minus 1. See, if jn is cos to the power nx, then cos to the power n minus 2x would be jn minus 2. So it would be jn minus 2 minus n minus 1 into jn. And if we take this in left hand side, this will be plus jn, here it will be minus jn. So minus jn plus jn will cancel out. Where it is minus njn, it will be plus njn. Cos to the power n minus 1x into sin x plus n minus 1 into j n minus 2. So ultimately we get jn as cos to the power n minus 1 x sin x upon n plus n minus 1 by n into j n minus 2. That is the formula you have to remember. Okay. Now let us see our fourth reduction formula, which is integration 0 to pi by 2 cos to the power nx dx. Okay, and it will be, let us say this is your in, then I am writing the formula only. I think you have got the point how to derive these relations. From this you can get this limit, right? So in would be n minus 1 by n into I n minus 2. Is similar as we have derived for integration 0 to pi by 2 sine of n minus 1. So it is n minus 1 by n into I of n minus 2. It's the same formula. Same formula we got, right? So let us see one example regarding this. Let us say we have to derive, we have to evaluate integration 0 to pi by 2 cos to the power 7x dx. So it is in the same format. So in is n minus 1 by n into I n minus 2. So we need 7. So what would be I7? I7 would be 6, 7 minus 1, that is 6 by 7 into I5. What would be I5? I5 would be 4 by 5 into I3. What would be I3? I3 would be 2 by 3 into I1. What would be I1? I1. This is your In, that means cosine of x dx. So this will be integration 0 to pi by 2 cosine of x dx. And cosine of x is sine of x from 0 to pi by 2. Sine pi by 2 is 1, sine 0 is 0. So this integral is 1. So what is I7? I7 is 6 by 7 into I5. I5 is 4 by 5 into I3. I3 is 2 by 3 into I1. I1 is 1. So this is the answer. If you calculate, you will get 16 by 35. Now let us see our fifth reduction formula, which is for integration sine to the power mx cos to the power nx dx. Okay, so this integration would be, let us say we have defined this integration as j m comma n. This is integration of this sine to the power mx cos to the power nx dx. So our formula would be sine to the power m plus 1 x cos to the power n minus 1 x upon m plus n plus n minus 1 by m plus n into j m comma n minus 2. This is the formula you have to remember. Okay. Now you can write this formula in this format also. This is in one format. Your gm comma n, you can write this as sine to the power m minus 1x cos to the power n plus 1x by m plus n plus m minus 1 by m plus n into j m minus 2 comma n. You can use this formula also. Okay. Now let us see our next reduction formula. If you have limit here, let us say I m comma n is integration 0 to pi by 2 sine to the power mx cos to the power nx dx. Then this integral would be I m comma n. This would be n minus 1 by m plus n into I m comma n minus 2. If we use this formula, we will get this. And if you use this formula, you will get I m comma n is m minus 1 by m plus n into I m minus 2 comma n. Okay. Both of the formulas are valid. And finally note one thing, that I m comma n is similar as I n comma m. Okay. Now let us see our let us say this is our first formula, this is our second formula. So integration 0 to pi by 2 sine to the power mx cos to the power nx dx would be, you can write this as I m comma n as 2, 4, 6 up to m minus 1 divided by n plus 1, n plus 3 up to n plus m, when m is odd and n may be odd or even integer. Remember this. And this will be 1, 3, 5 up to m minus 1 into 1, 3, 5 up to n minus 1. Okay, upon 2, 4, 6 up to m plus n into pi by 2 when both m and n are even integer. If both are even integer, you have to use this formula. If m is a odd integer and n may be even or odd, you can use this formula. So let us see some examples so that it will be clear. We have to evaluate integration 0 to pi by 2 sin to the power 6x cos to the power 8x dx. So both are even, right? M and n both are even. So we have to use this formula. That is 1, 3, 5 up to m minus 1. M is 6, 6 minus 1, 5. That's all. Again 1, 3, 5 up to n minus 1. That is 8 minus 1 is 7. So next term would be 7. And in the denominator, we have m plus n, that is 8 plus 6, 14. So it will go 2, 4, 6, 8, 10, 12, 14 into pi by 2. So if you calculate, you will get 5 pi by 4096. Let us see another example. We have to evaluate integration 0 to pi by 2 sin to the power 5x into cos to the power 6x dx. Here m is odd and n is even. So you have to use the first formula. It would be 2, 4 up to m minus 1, that is 5 minus 1, 4. So you have to stop here. Then m plus n up to m plus n. So this will be n plus 1. N is 6, 6 plus 1 is 7. Then 9, then 11. M plus n is 11. So you have to stop here. N plus 1, n plus 3. Okay. Now n is 6, 6 plus 1 is 7. 6 plus 3 is 9. Okay. Then 6 plus 5 is 11. If you calculate, you will get 8 by 693. Okay. Now remember, in the formula we have sin to the power mx, cos to the power nx. Now let us see another example. We have to evaluate integration 0 to pi by 2 sin to the power 6x cos to the power 5x dx. But we don't have any formula for this. We have formulas for if m is odd, that is sin to the power mx. M is odd and n may be even or odd, and if both are even. But here sin is even, cos is odd. So we cannot use the formula. So we know if we have integration 0 to a f of x dx, we can write it as 0 to a f of a minus x dx. So it will be integration 0 to pi by 2 sin to the power 6 pi by 2 minus x cos to the power 5 pi by 2 minus x dx. Sin 90 degree minus theta, it will be cos theta. So 0 to pi by 2, this will be cos to the power 6x, and this will be cos pi by 2 minus x would be sine. So it will be sine to the power 5x dx. Now here m is odd, n is even. So this is in the same format just we have derived. This is 8 by 693. Okay. Now let us see our next reduction formula, that is number 7. This is integration cos to the power mx sine nx dx. Let us say it is j m comma n. So our formula would be, this formula would be minus cos to the power mx into cos nx by m plus n plus m by m plus n into j m minus 1 n minus 1. That is the formula you have to remember. Okay. Now let us see number 8. That is if we put limit here 0 to pi by 2. So let I m comma n is integration 0 to pi by 2 cos to the power mx sine nx dx. So it would be, if you derive, you will get 1 by m plus n plus m by m plus n into I m minus 1 n minus 1. That is the formula you have to remember. Okay. Now let us see one example regarding this, so it will be more clear. We have to evaluate integration 0 to pi by 2 cos to the power 4x into sine 3x dx. So this is exactly in the same format. M is 4, n is 3. So it would be 1 by 4 plus 3 plus 4 by 4 plus 3 into I m minus 1. 4 minus 1 is 3, n minus 1, 3 minus 1 is 2. Okay. Now we have to apply for I 3 comma 2, right? I 3 comma 2 here. So it will be 1 by 7 plus 4 by 7 into, again use the formula, in place of m we have 3 now, in place of n we have 2 now. So it will be 1 by 3 plus 2 plus 3 by 3 plus 2, I 3 minus 1 is 2, I 2 minus 1 is 1. Okay. Now we have 1 by 7 plus 4 by 7, and this is 1 by 5 plus 3 by 5 I 2 comma 1. Again use the formula, in place of m we have 2, in place of n we have 1. So let us say I 2 comma 1 is integration 0 to pi by 2 cos square x into sin x dx. Now we have to evaluate this. See here we can write 0 to pi by 2 cos square x. We can write sin x dx as d of cosine of x. The differentiation of cosine of x would be sine of x minus sine of x. So we will need minus here. Now this is x to the power n dx formula, right? Minus x to the power n plus 1 by n plus 1. So cos to the power n plus 1, that is 2 plus 1, that is 3 by 2 plus 1, that is 3. So this is 0 to pi by 2. And if you put the limit, cos pi by 2 is 0, cos 0 is 1. So minus minus plus, it would be 1/3, right? So our answer would be 1 by 7 plus 4 by 35 plus 12 by 35 into I21 is 1 by 3. And if you evaluate, you will get 13 by 35. This is the answer. Okay. Now, let us see some questions. Show that integration 0 to 1 x to the power 6 dx by square root of 1 minus x square. This is 5 by 12 pi. We have to evaluate. Show this. So let us see the answer. See, this is integration 0 to 1 x to the power 6 dx by square root of 1 minus x square. So let x is sin theta. So our integration would be, if you put 0, sin 0 would be 0, and if you put x equals to 1, sin inverse 1 is pi by 2. So limit is from 0 to pi by 2. This is sin to the power 6 theta. And if you differentiate, it will be dx equals to cos theta d theta. So you will write cos theta d theta. Square root of 1 minus sin square theta, that is cos square theta. Square and square root will cancel out. It will be cosine of theta. It will cancel out. So you got integration 0 to pi by 2 sin to the power 6 theta d theta. It is exactly in the format integration 0 to pi by 2 sin to the power mx sin to the power nx dx. What is the formula? Formula is n minus 1 by n I n minus 2, right? This is our formula. So let us see. It will be our, or we can okay. So this should be n minus 1, that is 5 by n, that is 6 into I n minus 2. So n minus 2 would be 6 minus 2, that is 4. So we have to calculate I4. So what would be I4? I4. Okay. Let us remember, we have In is n minus 1 by n into I n minus 2. So if you calculate I4, you will get 4 minus 1, that is 3. So 3 by 4 into I2. Now what would be I2? I2 would be 2 minus 1, that is 1 by 2 I0. Now let us calculate I0. So I0 would be integration 0 to pi by 2 sin to the power 0x dx or 0 theta d theta. So it would be only d theta, only pi by 2. So we can say that our in is, this is our 5 by 6 into I4. I4 is 3 by 4, I2. I2 is 1 by 2, I0. I0 is 5 by 2. Okay. Now if you evaluate, you will get 5 pi by 32. That's how you have to apply the reduction formula. Let us see another question. Prove that if u of n is integration 0 to 1 x to the power n tan inverse x dx, then n plus 1 u of n plus n minus 1 u of n minus 2 is pi by 2 minus 1 by n. So let's prove this. We have un as integration 0 to 1 x to the power n tan inverse x dx. So let's apply by parts here. Okay, let us say here we have to apply Euler inverse logarithmic algebraic trigonometric exponential. So here we have inverse and algebraic. The inverse function should be taken as first function. So this is our first function. This is our second function. So let's apply by parts here. So tan inverse x integration of x to the power n, that is x to the power n plus 1 by n plus 1. See, if you have u into v dx, let us say this is your first function, this is your second function, then by parts is keeping first function out of the integration into v dx minus integration ddx of u into integration v dx again dx. This is the format of by parts. Okay, now let's apply. So it would be from 0 to 1 minus integration 0 to 1 ddx of u. First function is tan inverse x and differentiation is 1 by 1 plus x square into integration of v dx. This is this thing, x to the power n plus 1 by n plus 1 into dx. So let's move forward. If you put 1, tan inverse 1 is pi by 4, and here you will get 1 to the power something, that is 1 by n plus 1. So you have pi by 4 into 1 by n plus 1, and if you put 0, tan inverse 0 is 0. So whole thing would be 0. Minus 1 by n plus 1 integration 0 to 1, and you can write this 1 by 1 plus x square as 1 minus 1 by 1 plus x square into x to the power n minus 1 dx. See, if we do LCM, it would be 1 minus 1 plus x square minus 1. So x square by 1 plus x square. If you add x square, that is n minus 1 plus 2, it will be n plus 1. Okay. So this will be pi by 4 into 1 by n plus 1 minus 1 by n plus 1 into integration 1 into this thing, that is 0 to 1 x to the power n minus 1 dx minus minus plus, it will be 1 by n plus 1 into integration 0 to 1 by 1 plus x square x to the power n minus 1 dx. Okay, now let us see our next step, that is integration. We have to do the integration here. See, let us say we have to solve this integration 0 to 1 by 1 plus x square x to the power n minus 1 dx. Okay, now let us say here both of the are algebraic functions, so you have to be very careful choosing the function 1 and function 2. If we choose function 1 here, x to the power n minus 1, this is your function 1. Let us say this is your function 2. So x to the power n minus 1, integration of 1 by 1 plus x square dx. This is tan inverse x formula from 0 to 1 minus integration 0 to 1 ddx of x to the power n minus 1. This would be n minus 1 x to the power n minus 2 into integration of 1 by 1 plus x square, that is tan inverse x dx, right? So you can say from this line it is pi by 4 into 1 by n plus 1 minus 1 by n plus 1 into, this would be x to the power n minus 1 plus 1 by n minus 1 plus 1. So integration will be x to the power n minus 1 plus 1 by n minus 1 plus 1 from 0 to 1. So it will be x to the power n by n. If we put 1, it will be 1 by n. If we put 0, it will be 0. So you got 1 by n plus 1 by n plus 1, and integration of this thing, you got this, right? So 1 by n plus 1 into this 1 by n plus 1 is multiplied with this whole term, right? So 1 by n plus 1 of this thing. If you put 1, you will get pi by 4. And if you put 0, tan inverse 0 is 0. So minus this n minus 1 will go outside. N minus 1 by n plus 1 into integration 0 to 1 x to the power n minus 2 tan inverse x dx, right? So if you take 1 by n plus 1 common, you will have pi by 2 minus 1 by n minus n minus 1 by n plus 1 into, this is your u of n minus 2. So ultimately we got n plus 1. If we multiply n plus 1, u of n plus n minus 1 u of n minus 2 is pi by 2 minus 1 by n. That's all we have to prove, right? There is a thing we have to prove. So hence it is proved. So you have to be very careful choosing and solving this type of question. Let us solve another question, and we'll wrap up our lecture. If I of n is integration 0 to pi by 2 x to the power n sine of x dx, where n is greater than 1, show that I of n plus n into n minus 1 I of n minus 2 is n into pi by 2 to the power n minus 1. Okay, I of n is integration 0 to pi by 2 x to the power n sin x dx. So here we have sine and x to the power n, algebraic and trigonometric function. So this would be our function 1 and this would be our function 2 if we apply Euler rule. So this would be x to the power n, integration of sin x is minus cosine of x from 0 to pi by 2 minus integration 0 to pi by 2 n into x to the power n minus 1 into minus cosine of x dx. So if you put pi by 2, cos 90 0 and x 0 0. So this whole term will be 0. So this would be minus minus plus n into integration 0 to pi by 2 x to the power n minus 1 into cosine of x dx. So let's bypass it again. This is your first function, this is your second function. So it will be n into x to the power n minus 1 sine of x, integration of cosine of x is sine of x from 0 to pi by 2 minus integration 0 to pi by 2 n minus 1 into x to the power n minus 2 into sine of x dx. So this would be n. If you put pi by 2, sine pi by 2 is 1. So this is pi by 2 to the power n minus 1 minus n minus 1 into integration 0 to pi by 2 x to the power n minus 2 into sine of x dx. So this would be n into pi by 2 to the power n minus 1 and this would be minus n into n minus 1. This is your I n minus 2. Okay, this is your I n. So we can say that I of n plus n into n minus 1 I of n minus 2 is n into pi by 2 to the power n minus 1. That's all we have to prove. So I think you have understood how to solve this type of questions. So practice 5 to 10 questions on your own and the job will be done. So that's all for today. Thank you. Have a good day and take care of yourself.